Hi, trigonometry class. I've put together a little chapter 3 review for you, so let's go ahead and get started. Just note that all of these problems that I go through on this chapter review aren't necessarily going to be on the test, especially whenever I show you some of the application problems. Not all of these application problems. I'm just wanting to for y'all to get a feel of what types of problems will be on the test, but some of them may be very similar to what you see in this review. All right, so first couple of problems are going to be conversion problems where you're asked to convert from degree measures to radians and then radians to degrees. So the first one here, it says, let's convert negative 20 degrees. Well, we convert it to radians rather than degrees. So to convert, we need to multiply by pi over 180 degrees. And when we do that, we get, you can go ahead and reduce this fraction at this point. I'm just showing y'all this all multiplies straight across together. And reducing the 20 over 180 fraction, you get negative pi over 90. And that is your answer. So anytime it says this right here, leave radian answers in multiples of pi, that means leave pi in it. Do not multiply pi through and give me a decimal answer. Okay, on the second one, it says negative 9 pi over 2. This is in radians because there's not a degree symbol above it. So this is understood to be in radians. So convert this to degrees. And how you convert is similar to this one over here. Instead of multiplying by pi over 180, we are going to multiply by 180 degrees over pi. And these pi's end up canceling. And when we multiply this all together, we get negative 810 degrees. And that's it. Okay, on this next slide here, I have for you are some problems that you'll be asked to find the exact circular function value. So you will have the use of your unit circle, and so use it to find these values right here. What I will tell you, if you have something that is less than 0, like a negative value inside your trig function, or something greater than 2 pi, like I do have in this problem below, the cotangent of 13 pi over 6. Get it to be somewhere between 0 and 2 pi, somewhere along this unit circle, by adding or subtracting 2 pi how many ever times you need to get it somewhere between 0 and 2 pi. So on the first, whoops, sorry. Okay, on this one, on the first one where it says sine of negative 2 pi over 3, what we'll do is add 2 pi to this. So we can get a coterminal angle somewhere between 0 and 2 pi. And what we get here is, well, if we're multiplying, sorry, not multiplying, but adding fractions, we need to get a common denominator. And that would be 3. So 6 pi over 3. Add that together, we get 4 pi over 3. So the sine of negative 2 pi over 3 is the same thing as finding sine of, not negative, I don't know why I said negative. Goodness. But it's 4 pi over 3. Sorry guys for the jumping around. I'm having issues with my writing pad, obviously. There we go. This is equal to, now go over to your unit circle, find 4 pi over 3, and that is right here. Now, since you're finding the sine value of this angle, sine of your angle is equal to your y value. So that's where this comes in handy right here. Sine of 4 pi over 3 is the negative square root of 3 over 2. And that is what you'll write. Negative square root of 3 over 2 is your answer. Now cotangent, again, this is greater than 2 pi, so get it somewhere between 0 and 2 pi. So we're going to subtract 2 pi. Getting a common denominator between the two, we end up getting minus 12 pi over 6. So that reduces to 6 pi. Finding the cotangent of 13 pi over 6 is the same as finding the cotangent of pi over 6. So go to your pi over 6 values. That's it right here. Remember, cotangent is x over y. And whenever you put x over y, you get square root of 3 over 2 divided by 1/2. That reduces to, I'm going to come down here and do that, this right here. So square root of 3 over 2 times the reciprocal of this. So you get square root of 3 as your answer for this function value there. Now, on this one, it says find the exact value of s in the given interval that has the given circular function value. Okay, so here you are given the interval to find your value of s on 0 to pi over 2. That is the first quadrant right here. So your value is going to come from here. It's either going to be pi over 6, pi over 4, or pi over 3. And you have to determine that by knowing, well, cotangent is equal to your x over your y, like we said in the previous slide. Which of these two x and y values can you divide and it will equal 1? Well, there's only one solution to that, and that's this one right here. These two values are the same, and when you divide two values that are the same, you get 1. So pi over 4 is the one that we are looking for. So s will equal pi over 4. Now on this, you will actually have these same exact directions. It says find the value of s in the interval of 0 to pi over 2 that makes the statement true. Round to 4 decimal places. Okay, so you will have what number to round to and everything. For this first one, to find s, remember, to find your angle, you need to take the inverse cosine or inverse trig function. Gosh. Okay, so I'm going to say cosine inverse of my 0.8654. That is equal to your s. And you just type that into your calculator. Make sure you put it in correctly, cosine inverse. And this is what I get, 0.5248. And there you go. And this should be in radians. And because it says this right here, 0 to pi over 2, this is in radians right here, the interval that you're given. So you're not going to give it to me in degrees. And make sure your calculator is in radian mode rather than degrees. Okay. Okay, here we go. On this one, since we have a reciprocal function here, rewrite it in the form of your reciprocal function of this, which is cosine. Cosine of s is equal to 1 over this number. Okay, so now do the same thing we did here. Take the cosine inverse to find s. plug that into your calculator, and that will be your S value. And this is what I got for it. 3. Okay. All right, let's keep on moving. Okay, here's first of a few application problems that I have for you. It says assume that the cities lie on the same north-south line and that the radius of the Earth is 6,400 kilometers. Find the latitude of Winnipeg, Canada, if Winnipeg and Austin, Texas, Texas lies on this latitude right here, are this many kilometers apart. So what we have here is this here. I'm going to draw it out for you. So we have the Earth. There we go. Here's the equator, and above the equator line we have 30 degrees right here, and that is where Austin, Texas lies. Is at that point right there. And then we are given that Austin, Texas and Winnipeg, Canada are so many kilometers apart, which we are given it's 2,234 kilometers. That there is this arc length right here, your distance for your S. In your formula, S equals R times theta. So we are trying to figure out what is this right here, what is that angle, whenever we plug in everything here. So arc length is this here, and our radius is the radius of the Earth, which we're given. So solve for theta. Divide both sides by this 6,400. And you get this right here. Let's see. I went ahead and just reduced the fraction. Okay. Now to put it in degrees, because we need to figure out what latitude it lies on, we need to convert to this. Let's see. 180 over pi. Give us the correct conversion there. And it's approximately, let me go back, it's approximately 20 degrees. My calculator gave me 19.999 something. But anyway, so that is this distance right here, or this angle measure for theta. To find the latitude, what we need to do is take our 20 degrees that we found our angle to be, and then add it to our already 30 degree north latitude there. So 30 degrees here, 20 degrees here. Our latitude for Winnipeg, Canada is 50 degrees north. And that's how you go about it. Okay, another problem here. It says a bicycle with 26-inch wheel. This is in diameters, so be careful whenever you have diameter given to you. Most of your formulas are use radius rather than diameter. Okay, it travels a distance of 800 feet. How many revolutions does the wheel make? And we're going to round to the nearest revolution. All right, so this is how I would go about it. Well, we are given diameter is 26 inches. We need radius, so divide it by 2. You get 13 inches. All right, and the amount of distance that it's traveled, well, that is your arc length. Okay, so 800 feet. I'm going to convert that to inches. Since our radius is in inches, I'm going to make our arc length in inches also. Okay, so now that we have our arc length and we have our radius, use your arc length formula right here to find theta. Now, let's see, we got this. Divide both sides by 13. And that's what we get. Now, it asks how many revolutions does the wheel make? Now, for revolutions, there are, in one revolution, there is 2 pi radians, okay? This right here, the 9600 over 13, that is a radian measurement. If we multiply this radian measurement by, let's see, we want it in revolutions, so multiply it by 1 revolution, that is over 2 pi radians. We end up canceling our radians out right there. And we have it now, our answer is going to be in how many revolutions this is. So multiply the 9600 over 13 and then, well, divide it by 2 pi. And you get, let's see, what did I get? Okay, to the nearest revolution. Whoops. Sorry, guys. Okay, I get approximately 118 revolutions. So on this one, we're kind of just going backwards. Sometimes we have been given how fast something is going in like revolutions per minute, and we convert that to radians per minute, okay? So this one we solve for radians, and we convert the radians to revolutions by this conversion here. All right, so this next one, it says a car wheel has 13-inch radius. Through what angle to the nearest tenth of a degree does the wheel turn when the car rolls forward 2 feet? Okay, so very similar to the last one, actually. So, shoot. There. So let's look at this. We have radius, it's 13 inches. And then we're asked what angle to the nearest degree does the wheel turn when the car rolls forward 2 feet. Again, that measurement given to you is going to be your arc length. So 2 feet. Again, make the radius and your arc length agree. So in the unit of measurement, to convert that to inches or convert this to feet. I don't care either way. So now, let's do this. We have 12 inches, so we have 24 inches here. And then let's see how we use our arc length formula. S equals R times theta. Plug in 24 here, 13 here. Solve for theta. So theta is 24 over 13. Multiply this by, because you're asked for the degree measurement, multiply it by 180. 180 degrees over pi to get our radian measurement, or sorry, our degree measurement, which my calculator tells me is 25.56. So rounding to the nearest degree, that is going to give us 26 degrees. And we are done with that one. All right, so this question is a lot like one of your quiz questions from the last quiz that we took. We're going to be using both arc length and area of a sector formula in this right here. I'm going to go ahead and write those down. So area equals 1/2 r squared theta, and arc length. Okay, so it says a circular sector has an area of 200 square feet. The radius of a circle is 10 feet. What is the arc length of the sector? So what we need to do is take our area that we are given, plug it in, and then also our radius that we are given, plug that in too, and solve for theta. So when you solve for theta, get this, and so we get 4. So that right there, again, is in radians. We can go ahead and plug that straight into this formula here because we're asked what is the arc length of the sector. So arc length is S equals our radius, which is 10, times 4, because that's our theta that we solved for, and that is equal to 40. And your unit of measurement is going to be in feet, because square feet here, radius is in feet also. Okay, now let's look at one last problem. All right, so other than this one problem right here that deals with our last section of problems, this is going to be similar to the one and only application problem that you have on your test. But you will have other problems similar to your homework problems where it asks you to solve for, like if you were given v equals r times the angular speed, and you're given the linear speed, whoops, if you're given the linear speed and the angular speed, what is the radius? So solve for the missing variable is what you're going to be asked to do on a couple of problems. Okay, this problem here, let's look at it. A wheel with 18-inch diameter, and again, it says diameter, not radius, is turning at a rate of 48 revolutions per minute. To the nearest inch, what is the speed of the point on the rim in inches per minute? So speed means find not the angular speed, but the linear speed. Okay, so diameter, that's 18 inches. So radius is going to be half that. All right. Angular speed, this is how you come up with angular speed. Especially whenever you're given 48 revolutions per minute, what your angular speed is going to be is, well, it's 48 revolutions per minute. And whenever you have revolutions per minute, make sure you multiply by 2 pi, because there are 2 pi radians in 1 revolution. Okay? So all of that ends up equaling, let's see, 96 pi radians. So this is our angular speed right here. So anytime, like I said, you're given revolutions per whatever, multiply it by 2 pi radians, and you've got your radians per whatever time measurement you're given. I'm glad this video is almost over. Anyway, here we go. Linear speed. We are given the radius. Well, we're given diameter, but we found the radius. And we found the angular speed. So use this formula right here. V equals r times your angular speed. No makeup. Plug away. You have 9 times the 96 pi. Okay. And just, it says to the nearest inch, so nearest whole number is what we're going to round this to. So plug all of this into your calculator, 9 times 96 times pi, and you'll get this number here. And make sure you put your unit of measurement on the end. The radius is in inches, and this is in radians per minute. So your overall speed here is going to be in inches per minute, because we're going to drop the radians when we have a distance of some sort given to us. And that is it. That's all I have for you. So study hard. Hope y'all do all do well, and I hope this video helped you out. I'll see you guys tomorrow in class. Goodbye, everybody.